Imagine a weapon that fires a near-boiling chemical spray, a weapon that can aim in almost any direction, tracking a moving target with a flexible turret. Now imagine this weapon belongs to an insect the length of your fingernail. Out of the leaf litter comes a sound like crackling static, a puff of acrid vapor, and a predator that suddenly, painfully, regrets its choice of meal. This isn't science fiction. This is the Bombardier Beetle, a tiny chemical engineer that has packed a combustion engine into its abdomen. At a glance, Bombardier beetles are unassuming. They are a widespread group of ground beetles, found on every continent except Antarctica. You can find them scurrying under stones, along the damp edges of rivers, or deep in the forest floor's complex tapestry of decaying leaves. Most are just 5 to 15 millimeters long, dark little specks of armored life going about their business. They are hunters, stalking other small invertebrates in the twilight of the undergrowth. But they are also the hunted, and that is where their ordinary story ends, and their extraordinary one begins. To survive in a world of hungry spiders, ants, frogs, and birds, they became masters of chemical warfare. So, how does it work? The secret is in a design that any rocket scientist would recognize, keeping a fuel and an oxidizer stored separately until the moment of ignition. Inside the Beetle, a pair of glands work like tiny chemical factories, producing two liquids. The first is a solution of hydroquinones, the fuel. The second is concentrated hydrogen peroxide, the oxidizer. Each is stored safely in its own reservoir. When danger strikes, the beetle contracts the muscles around these reservoirs. This forces a small amount of each liquid through a one-way valve and into a third, very special chamber. This is the reaction chamber. Its walls are thick, reinforced with proteins and chitin, like a tiny bioceramic pot built to withstand extreme heat and pressure. The chamber's inner walls aren't smooth. They are lined with a dense coat of enzymes, specifically catalyses and peroxidases. These enzymes are hyper-efficient catalysts. The instant the fuel and oxidizer hit this lining, the reaction is explosive. The enzymes tear the hydrogen peroxide apart, releasing free oxygen. This oxygen instantly oxidizes the hydroquinones, transforming them into a toxic, irritating class of chemicals called benzoquinones. This entire chain reaction is violently exothermic, meaning it releases a tremendous amount of energy as heat. In a fraction of a second, the temperature inside the chamber spikes to 100 degrees Celsius, the boiling point of water. The reaction also releases a huge volume of gas, mainly oxygen. The pressure skyrockets inside the tiny armored pot, and there's only one way out, a narrow nozzle at the tip of the beetle's abdomen. The superheated, toxic slurry is blasted out as a fine, searing jet. For decades, scientists thought this was a single, powerful blast. But when high-speed cameras were finally turned on the Beetle, they revealed something even more remarkable. The Beetle doesn't fire a continuous stream. It fires in a rapid-fire volley of micro-explosions. Some species can produce up to 500 pulses per second. Each pulse makes its own audible pop, which blend together into a distinctive crackling sound. This stuttering isn't a flaw, it's a brilliant piece of engineering with three key advantages. First, it protects the beetle from its own weapon. Each tiny explosion vents, and for a microsecond, the chamber pressure drops, preventing a catastrophic rupture. Second, pulsing allows for rapid-fire course correction. The beetle can literally walk its aim across a moving target, peppering an ant's leg, then its antenna, then its eye. And third, it gives the beetle fine control. It can deliver a short warning burst or a long sustained volley depending on the threat, conserving its precious chemical ammunition. Having a powerful weapon is one thing. Being able to aim it is another. The Bombardier Beetle's second superpower is its incredible targeting system. The last few segments of its abdomen are connected by flexible membranes, creating a highly mobile turret. It can swing the nozzle left and right, covering an arc of nearly 270 degrees. It can also lift the tip, curling it forward over its own back to shoot a predator attacking from above or one that has grabbed a leg. We've seen this in stunning high-speed footage. An ant rushes in from the side, and the beetle, without moving its legs, swivels its abdomen and lands a volley directly on the ant's head. The ant instantly recoils, frantically grooming the burning quinones from its antennae. A hunting spider might manage to grab the beetle's leg, only for the beetle to aim its nozzle over its own body and fire point blank into the spider's sensitive eyes. The spider immediately lets go and retreats. The battle is over before it truly begins, ended by a perfectly aimed shot. But what if the predator is too fast? What if the beetle is swallowed whole? For most insects, that's game over, but for the Bombardier beetle, it's just a change of venue. In a series of astonishing experiments, Japanese entomologist Shinji Sugiura and his team fed Bombardier beetles to various species of frogs and toads. The amphibian's tongue would flash out, the beetle would disappear, and for a moment all seemed lost. But then, from inside the predator came a muffled but unmistakable series of pops. The toad would begin to gag, its body convulsing, and then, in a dramatic upheaval, it would vomit, spitting the beetle back out onto the ground. Covered in stomach juices but very much alive, the beetle would simply clean itself off and walk away. In these studies, the beetle's survival rate was astonishingly high. The chemical defense was so potent, a combination of boiling heat and noxious chemicals, that it triggered an inescapable reflex in the predator. The beetle's weapon works in total darkness, in an acid bath, from inside the belly of the beast. It's perhaps one of the most incredible escape acts in the entire animal kingdom. Of course, this incredible power comes at a cost. Manufacturing these complex chemicals requires a lot of energy. The beetle's reservoirs are not bottomless. After firing several long volleys, its ammunition can run low, leaving it vulnerable while it slowly synthesizes a new batch. This means the beetle must be strategic. It can't afford to be trigger-happy. A short burst might be enough to deter a curious ant, saving the bigger volleys for a truly life-threatening encounter with a toad. The beetle's own safety is also a marvel of engineering. That one-way valve between the reservoirs and the reaction chamber is critical. If the explosive pressure were to backfire, it would be fatal. The entire system, the separate storage, the armored chamber, the controlled pulsing, the strategic use of ammunition, is a masterclass in evolutionary design, balancing immense power with delicate control. If you appreciate these deep looks into the strange and wonderful tools of survival, consider subscribing to Faunary. We explore the hidden marvels of the animal world every week. Take a moment to appreciate the sheer improbability of it. An insect living a quiet life under a rock has evolved an internal combustion engine. It manages high-pressure chemistry, near boiling temperatures, and precision targeting, all with machinery built from the same stuff as its own skin. It's a walking, six-legged testament to the strange and beautiful paths that survival can take. Evolution, working through millions of years of tiny advantages, turned a simple ground beetle into a master of the micro-explosion. The world is full of these hidden wonders, waiting in the leaf litter to be discovered.